Hello viewers, welcome back to our YouTube channel, and today we want to continue with our series of quantitative techniques. And in the previous video we had looked at the presentation of data. We had looked at the different aspects of how we can present both qualitative and quantitative techniques. But as a matter of emphasis, I want to do a precursor on what we discussed, and specifically when we talked about the group frequency distributions, because the other one, I believe, for the ungrouped frequency distribution and then the contingency tables, I believe we handled it very well. So the reason as why I'm emphasizing on the grouped frequency distribution is because we are going to deal with it more often when we are dealing with measure of central tendency, and then when you're dealing with measure of dispersion. So without wasting more time, let's try to look at the group T. Grouped frequency distribution. Grouped frequency distribution. So we said that when you are dealing with grouped frequency distribution, we look at organizing large data set or large sets of data into what we call intervals, the one that we call class intervals, to make patterns easier to see and be able to do the necessary analysis of the results that you have presented. So we basically arrange the data into what we call classes, and then we give their related frequencies. So when the data set is large, the data must be grouped into what we call classes. The data must be grouped into what we call classes, and of course these classes must have more than one unit in width. If I have a class of 20 to 30, at least the values I expect to be here, they must exceed 1. That maybe we have 20, 25, those are data values that are within that range or that interval of 30 to 20. But we said that each of these values, because each class is going to have numbers, it's going to show the numbers of the values that lie within that interval. As they give the numbers that lie within that interval, they also show their frequencies, or how many times these numbers exist. We may have in a class of, let's say, 20 to 25, and maybe we have 25 maybe 4 times. Maybe we have 24 3 times. Maybe we have 20 twice. So as long as within that interval the values that we have there exceed 1, we organize them into what we call classes, and those values will show their respective class frequencies. So we looked at some of the terminologies, because we are saying it is classes and then frequencies, or the class intervals and the class frequencies. So we needed to understand what are the types of classes that we have under these grouped frequency distributions. We said we have what we call inclusive classes, and we gave their related examples. We said that inclusive classes, this is where both the lower class limit and the upper class limit of a given class are included in that class. So it is particularly useful when the data is expressed in terms of whole numbers, or when we are dealing with the discrete data. So as long as we have too many distinct values, because we are going to have very many distinct values, that we can't employ the single value grouping that we did in the ungrouped data, we end up doing what we call classes. And these inclusive classes will include both the upper class limit and then the lower class limit. They are both included in that class. We gave an example. Of course, we said if let's say we have a class of 30 to, let's say 30 to 39, then we have maybe the other class, it starts from 40 to 49. So we find that this is the lower class limit and this is the upper class limit of that class. So both of these two elements are included within these values. So when we are counting, when you are picking out those numbers, even number 39 will be picked and it will be inclusive within this class 1. It will be inclusive. So the only numbers that we can't include in this class, they are the ones that are 39 point maybe 5. This one is not inclusive because it's above 39. So in this kind of analysis, the group, if we are, let's say we are dealing with 30 to 39 group or class, it applies to all other items or other classes. Even this, in this second class, this 40 is our lower class limit, and then this one is our upper class limit, and both are inclusive in that class. So if we find numbers that are maybe 49.4, they are not within this class. 49.01, they are not within this class, meaning they fall in the next class unless we are rounding off. And remember, we say that by the time you bring out these values, we always do the necessary rounding off. Those were the properties of table designs. So you have to understand that the inclusive classes, both the lower and the upper class limits, are included in that class. Then we had what we call the exclusive classes. And of course, for exclusive classes, we find that the upper class limit of a given class is going to be excluded in that class, but it will be included in the next class. That's the only difference. So if we are talking about the exclusive classes, you find that maybe the classes, maybe we have 30, let's take maybe 30 to 40, then 40 to 50, then maybe 50 to 60. So this is our lower class boundary, not boundary, it's our, actually for exclusive classes this will be the boundaries, but we shall get to understand how some of these things are done when we are doing computations. So this will be our lower class limit, and then this will be our upper class limit. Now this upper class limit in class 1 is not included in this class, it is included in the next class, because you are seeing this, the lower class of this second class is 40, meaning this 40 is not included in that class. The only we can go up to, it's like having 30 less or equal to 40. It's not less than or equal to, it's less than 40. That is the implication, meaning we can have 49, sorry, we can have 39.99. That will be included in this, but as long as it makes to 40, it will be included in the next class. So we've said that exclusive classes, these are classes where the upper class limit of a given class or classes are excluded in that class but included in the next class. So each class consists of a range of values. The smallest value that could go in that class is what we call the lower class boundary, the lower class limit. The lowest, this is the 30, which is the lowest. It is the class that could go in that class. The smallest value that could go in that class is what we call the lower class limit. Then the upper class limit is it refers to the highest value that could go in the next class. So it depends on what you are defining. When I'm defining an upper class limit of an exclusive class, you will see that this 40 is not belonging to this class. So it goes the upper class limit that belongs to the next class. But if I'm talking about the inclusive classes where we say that both the upper and the lower are included, then the definition may change a little bit. Because if you are defining the upper class limit here, you will just be talking about this as the upper class, the highest value of that class. So it depends on which class you are defining. But as you are giving a general definition, even if you just say that the upper class limit is you can say it is the lower class limit of the other higher class, it would be fine. So we've looked at the exclusive classes and we looked at the inclusive classes, but we had one last class which we called the open-ended classes, the open-ended class or classes, where we've said that these classes, you find that the lower class limits and the upper class limits are either known, so they could be either known, in some classes they could be known, in other classes they may not be known. So they are either not known, or they are too far away from the rest of the values. In other words, they are either too big or too small. You could call them outliers. It could be too small value, or it is a too big value to be part of that. Or they may change with time or with circumstances. And we've looked at some of them, and we said you can find classes that start with a less than, then maybe they give you 200, then maybe 200 to, let's say, 400. Then they start maybe from let's say 400 to they could also use the same less than signs. They say less than, maybe can maybe put 600. Then when it comes to this one, they can say that maybe this is 600, then they put a greater than sign. The implication is that these numbers, they could even be negatives as long as they are less than 200. So that's why you find that the value here is not defined, and even the value here is not defined, as they just assume that any value above 600. So those are the ones that we call open-ended classes. So it is very important for you to know the classes or the kind of grouping that you are going to internalize when you are looking at the questions. But there are also other critical terminologies that you need to know as you are constructing the grouped frequency distributions. One of the terminologies that you need to know is what we call the class limit. Of course, we have been explaining this, but class limits, we said that these are lower and then the upper values of a class or classes as described in the distribution. This represents, let me write it, this or these are the lower and upper. These are lower and upper values. You don't, if you are defining, don't say limits, you say values, because you can't define a word by repeating itself. Lower or upper values of classes or classes as described in the distribution. As described in the distribution. So the lower class limit, there are two. We said the lower class limit, the lower class limit, the lower class limit, of course, is it looks at the smallest value, that could go in a class. And then when you look at the upper class limit, of course this one is the largest value, that could go in a class if we are looking at inclusive classes. But if they are exclusive classes, then it is the highest value that could go in the next. It is the highest value. If you are looking at exclusive classes, it is the highest value of a given class that could go in the preceding or in the next class. The highest value, the largest value that could go in a class that could go in a class. The other category that we need to understand is what we call the class boundary. We need to understand these terminologies because we are going to use them and we need to know how to compute some of them. That's why I'm repeating myself, because I want to make sure that we get an understanding, a thorough understanding of some of these terminologies before we proceed to computations, because we are going to need all these terminologies in what we are going to be doing. So the class boundary, these are numbers. These are numbers used. These are numbers used to separate the classes. So that there are no gaps in the frequency distribution. So that there are no gaps. No gaps in the frequency distribution. So the gaps, of course, they are always due to the limits or the class limits that we have. For example, if we are looking at inclusive classes, now this one you also need to be careful because they can change. For inclusive classes, I want you to analyze the gaps that we are talking about. For inclusive classes, of course, these classes, they have the lower and upper values of classes. They have the lower and the upper values of classes that make common points between them. Classes that make common. The word is common, meaning they are similar points between them. We are going to look at them. Of course, we've said 30, let's say 30 to 49. It is 30 to 39. Let's just use a small d. Let's just use a small interval, class interval. 30 to 39, then 40 to 49. You are seeing from this point, from 30 to 40, there are 10. We have 10 numbers. Even from 39 to 49, there are 10. But now That is the class interval. We are also going to get that. Now there is a difference between the upper of this class. This is class 1. There is a difference between the upper limit of this class and then the lower limit of this class. There is a difference of 1. So that's the gap that we are talking about. That from 39 to 40, there is a gap of 1 that is left. Meaning, if you want to remove the gap from, let me just do it down here. Let me repeat these classes. We've said it is a 30 to 39 and 40 to 49. We've said that from here, this one and this one, there is what we call a gap. From 39 to 40, there is a gap because it will be 40 minus 39. That will give you a 1. There is a gap of one value. Now, if we want to remove this gap of 1, what we do, since it is a 1 and it is occurring between class 1 and class 2, we get the average. We get the average because the number that is within here is just 1. So we divide that number by 2. It will give us a 0.5. So if you want to remove the gaps from here and here, we just add the 0.5 and we also put a 0.5 here. So that when I get 40.5 plus the 39.5, I will not have that gap. It will be gone. So now the question is, if I want to get, because remember, we started from 30 here. But there are numbers below 30. Meaning on this one, we shall just take off. It will be 30 minus 0.5. So when we less off the 0.5, it means we have removed the other gap. The other gap of a 1 that we had there. That's the reason as why we always add a 0.5 as the depending on the difference. But we are going to see some of those things, how we do them practically. And we shall use also other methodologies to actually get to those points. You will be able to understand later as we move on. But what you have to understand is that for inclusive classes, we always have those lower and upper classes or upper values of classes that make a common point between them. Now, for exclusive classes, now there is a very big difference for exclusive classes. For exclusive classes, you'll find that if the class is 30 to 40, and then it is 40 to 50, then 50 to 60. So if you see between this and this, we don't have any gap. It is 40 minus 40 gives us 0. There is no gap. That's why we say that for exclusive classes, the class intervals themselves, they become the class boundary. You will understand when we move along. But what is important for you to understand is that the class boundaries, they are always there to just remove the gap between those two classes. those two separate classes. So how do we remove that? We said you go to the upper class boundary. For you to get the upper class boundary, you get the upper class limit. The upper class limit plus 0.5 times d, and this d represents the size of the difference. Then when we are looking at the lower class boundary, when we are looking at the lower class boundary, we get the lower class limit plus 0.5 times d, and our d is the size of the gap that exists between successive classes. So this formula applies even to the exclusive classes, but this d, we said d equals to the size of the gap that exists between successive classes. So that's what I told you, that if it is a 30 to 39, then 40 to 49, you get the difference between this and this. You'll find it is a 1. We multiply that difference, we took it by 2, and then we multiplied the 0.5 times that difference, which is a 1. It becomes a 0.5. We add to those two. If it is for exclusive, where we've said that these classes are actually not having any difference, maybe 30 to 40, then 40 to 50. You're seeing the difference between here is a 0, so it will be 0.5 times 0, which will give you 0. That's why we take these to be the class boundaries, and at the same time they are the class limits. So we shall understand how we do most of these things, but ideally, if the data entries are integers, we can either subtract a 0.5 from the lower limit to find the lower class boundary, and find the upper class limit, we just add a 0.5 to get, just like the way you are seeing it here, 30 to 39. Ideally, what you do, you just get this 30, which is the lower class limit. You get 30 minus 0.5. Then for the upper limit, you get 39 plus the 0.5. That's how we get the class boundary of each of the classes. So we are going to understand some of those things as we move along. But basically that's what we do. The upper class boundary of a class will be equal to the lower class boundary of the next higher class. So you can either use the formula, or you just get this. You just take off 0.5 from here, the lower class limit, and then you add what is there. So that's very important. Then let's look at these other terminologies. Remember, all these terminologies that we are trying to define, these are the terminologies that we are going to compute. The same way we talk about them here is the same way we are going to compute them. We have what we call the class width. Class width, class interval, class length, they mean the same thing. Now, of course, the class width, this is the distance, between lower, it can be lower, or let me put this one in bracket, or upper. I will show you how we get it. Lower or upper limits. Upper limits of consecutive classes. In other words, it's the difference between the lower limit of a class and the lower limit of the next higher class. So it can also be the numerical difference between the lower class boundary and then the upper class boundary. But remember, the class boundaries, they are not the same as the class limits. So let's maybe do some small computation to get the class width or the class length. If let's say I'm going for inclusive classes, it is 30 to 39, it is 40 to 49. They told us in the definition that it is the difference. If we are using, these are the class limits. If we are using the class limits, we just get the difference between the lower class limit of consecutive classes. This is class A, the consecutive class is this. So the lower limit, this is a lower limit, and this one is a lower limit. So we get 40 minus 30. That gives you a 10. That is a class width. Or it can be the difference between the upper class limit of the consecutive classes. It is this minus this. So it's a 49 minus 39. It also gives you a 10. So these are the class width. The other option, they told us we can use class boundaries. And the class boundaries, we say they are not the same as class limits. These are the class limits. Now, class boundaries, we said we just get the lower class limit, we take off 0.5. So it is 30. This is this one, 30 minus 0.5. It gives you a 29.5. 2. Then on this one, we add 0.5. So it will be a 39.5. For this one, it will be 40 minus 0.5. So it will be a 39.5. Then on this one, we add a 0.5. So it will be 49.5. And they told us we just get the difference. The difference, or the numerical difference, between the lower and the upper class boundary. This is the lower. This is the lower class boundary, and this is the upper. So they told us we take the difference between the upper class boundary minus the lower class boundary. So we take 39.5 minus 29.5. It also gives you a 10. And that 10 is going to be our class interval, or what you call the class width or class length, because it is just the distance between the lower class limit of the consecutive classes. Even if you are looking for the exclusive classes, it's still the same, because you are going to have 30 to 40, maybe 40 to 50. You also take the same, these are class limits, but we say that in this case the class limits, they are the same as the class boundaries, because here we don't have the difference. So for this one, this 30 will be a class limit, and at the same time it will be a class boundary. So we just take the difference. So it will be 40 minus 30, which gives you 10. Then if we go this side minus this, it will be 50 minus 40, also gives you 10. Those are the class width. So the same way we have seen those computations being done is the same way we are going to do them as we move to practical questions, because we are going to look at very many questions, especially to do with measure of central tendency, measure of dispersion, and even when you are doing some parts of skewness. So let's now look at what we call the range as another terminology. Range. Of course, we know range is just the difference between the maximum and the minimum data values or data entries. So this is the difference. This is the difference between the maximum or the highest maximum, difference between the maximum and the minimum, or the lowest data entry or entries. So the difference between the highest value and the lowest value is what we call the range. That is very easy to get. If they give you values, you pick out the highest and then you pick out the smallest, then you get the difference. The other one that I want us to look at is a class mark. Class mark, or what you call a class midpoint. Class midpoint. Class midpoint. So the class midpoint is just the sum, which is just the average. Actually, you take the average of the lower and the upper limits of a class, then you divide them by 2. You just get the average. So you just get the lower. Let me write the definition, because if I just say the average, someone may write it, may not understand it. This is the midpoint. So this is the sum of the lower class limit. This is not boundary but class limit. The lower class limit and upper class limit divided by 2. We divide by 2 because there are two numbers. We add in the lower and the upper, then we divide by 2. Let me write it in a formula way. Let me write it in a formula way. This is a midpoint. We said it is the lower. Let me even use a different color. So the lower class limit. The lower class limit plus the upper class limit, divided by 2. Divide by 2. That's how we get the midpoint. Then we can also look at the relative frequency. Of course, the relative frequency, we had computed it in the previous video, but let me also repeat it. Relative frequency. Of course, the relative frequency of a class, this is the percentage of the data that follows in a class. This is the percentage. This is the percentage or portion of data that falls in that class. So to find relative frequency, we can abbreviate it as RF. To find relative frequency, this can be, you get the class frequency over the total frequency. Total frequency, of course, times 100 because it's a percentage. Others can say frequency over total frequency, summation F, times 100. So those are some of the things that we need to understand. Maybe we can get just the steps, because I remember in the ungrouped data we gave steps for construction of a frequency distribution table. So we can also give steps for construction of the grouped frequency distribution table. So we are going to create what we call the frequency distribution table. So let's maybe write the steps or procedures. Steps for construction of grouped frequency distribution. Frequency distributions. I'm writing some of these steps with the thinking that there might be some students who have never done any statistics and they are doing it for the first time. That's why we are doing some of these things, but the steps are actually known. But it will also help you to quicken the process of how you can be able to do any number that relates to or that needs to do the frequency distribution, because we said we are going to be doing very many numbers, so there is no way you are going to skip it. And that's why I'm taking it step by step, giving even the information that may not be necessary, especially for someone who has had some training or some prior studies about statistics. The first step is to determine the classes. Determine the classes. You determine the classes. Of course, determining the classes, most of the times, or most questions that you will see, the classes will not exceed, they will be around 5 to 20 classes. It will be very weird for you to find a class with 50. You find data set with 50 classes. That would be abnormal. At least 5 to 20. At least 5, then at most 20. But of course, there are some data set that you might find it. But I'm just saying that at least 5 to 20 classes. And most of the times, the smallest number of a class is chosen for the smaller data set. In other words, if you are picking your first class, the first class, you should make sure that the lowest or the smallest value in the data set is included in that first class. Because if they give you a class that has maybe 1, 2, 3, then for you pick a class that starts at 5, maybe 5 to 10, you have skipped some data. That's why we are saying, if they have given you this class, it is better you start maybe with 1 to 5, so that you can incorporate in the data even that smallest value in the data set is going to be included. So it is very important for you to include the smallest value in the first class that you are creating. So you define some, we've said if you are defining, there should be at least 5 to 20 classes. That is how you can define. Then the second step is to find the highest and lowest. To find the highest and then the lowest value. Why do we need to find the highest and the smallest value? Is because we need to compute the class width. Because you will be given data that is just numbers. You will be given whole numbers, just numbers. They could be decimals, but they could be just numbers. So you have to identify the highest value and then the lowest value. When you are done with identifying the highest and the lowest, the third step is to find the range. Find the range or compute the range. And remember we talked about what a range is. A range, we said the highest value minus the lowest value. But now there are some classes, as we talked about, like for open-ended classes. Remember, for open-ended classes, we said the numbers could be too small or could be too big, and they are not given. The highest and the lowest are not given. So what are you going to do? In such situation, you can ignore this step. So you can ignore if it is necessary, and you only take maybe you take values based on your estimation, but you keep in mind, because if you are not given the highest and the lowest value, you keep in mind that at least you should have 5 classes in a given data set, because someone can, if they have not given you the data, someone can just create maybe like 2 classes and moves on. You'll find that you'll have data that will be very much concentrated and it will be hard for you to analyze. So you give at least, that's why we've said in the first step we determine the classes that we need to have at least 5, so that if data is spread in 5 classes, you can be able to internalize the data and see maybe where the data has concentrated most. Then you can also be able to do other mathematical computations that can help you to analyze the data better. So when you are looking for the range and you find that maybe the data set they have given you, you don't have the highest, you don't have those extreme values, then what you are going to do is called personal judgment. You just do a personal judgment, but bearing in mind that at least I should have 5 classes. That's what I'm focusing on. That you shouldn't have too small as in the number of classes, or you shouldn't have too many as in the number of classes. So now the fourth step, step number 4, is for us to find the width, to find the class width. The class width. Of course, how do we find the class width? By dividing the range we have computed in step 2, in step 3, by dividing the range. So we divide the range by the number of classes, and then we round up the value. We round up the value that we have got. You will understand when we are doing computations. But you have seen the reason as why we first determine the classes. Because if you are finding the class width, you divide by the number of classes that you have determined in step 1. But we round off some of these values. For example, you may get the class width at 3.5. Of course, you can round this to be 4, so that you take that class width or the class length. But don't over round. Like if the class is 3.5, then you say the 4 is not convenient for me. I can't round it to 4. I'm rounding it to 5. This is not good. You just do the normal rounding up. If it is a 3.4, please take the 4. Because some people may be used to certain numbers that I'm used to 5. Though in most of these numbers that you are going to attempt, you'll find that most of the times the class width is an odd number. It's not mandatory, but most of the times you'll find that the class width is an odd number, and it's actually preferred for it to be an odd number, but it's not mandatory. So that's step number 4. Let's look at step number 5. You will understand some of these things when we start the computations because they will be very easy. They will be practical. Number 5, step number 5, we select a starting point. A starting point. Of course, usually we always take the lower class. We always take the lower class value. We always pick the lower value, not even the lower class, because the classes are not yet formed. We are still forming. So we always take the lower or the smallest value to be the starting point. The smallest value or the lower value. You look at the data set, then you pick out the lower value. Most of the times, if you don't pick the lower value, make sure that you first understand what the lower value is. Then maybe you can pick any convenient number that is below, not above. You pick any convenient number that is less than the smallest value. If the smallest value is, let's say, 3, and maybe my class width is 4, I can say for me my convenient value, because of the fact that the smallest value is 3, I'm taking a 2. So that if I'm to add a 2 plus a 4, I'm getting a 6 for my other classes. Or I can stick with the 3, and I start with the 3. But I can pick a 2, a number that is lower than the lowest value. Because for me to form that class, I will need a 2 plus the class width, then I get the upper class limit. So the class will be 2 to 6. So it depends on what you have selected and the class that you want to formulate. So we always pick the lowest value or any value that is convenient for us, as long as it is less than the lowest value. And then we add the class width to the lower limit to find our upper class, just like what I've done here. If my convenient number was a 2, then that 2 will be my starting point. It will be a 2, 2. Now I get my class width. If my class width is 4, then I will get 2, which is my starting point. I add the class width of 4. Whatever I get becomes my upper class limit for that class, which is a 6. So that's step number 5. Then step number 6. Step number 6 is for us to find the boundaries, the class boundaries. Find the class boundaries. Find the class boundaries. Of course, we know how to find those class boundaries. We said we subtract 0.5 from our lower class limit, and then we add 0.5 to our upper class limit, or you use the formula. Step 7, we tally the data. We tally the data. Tally the data. Then step 8, of course, is finding the numerical frequency. Finding the numerical frequency. find the numerical frequencies from the tallies. From the tallies. And of course, you can go ahead to compute the cumulative frequency and other stuff, depending on the question that you have. So those are the steps that we can go through to compute what we call the cumulative frequency table. But one thing that I need to note is for us to know how we get the number of classes. That step number one, number of classes. At some point you may need to do some small computations just to make yourself easy, to make life easy for you. How can we be able to compute the classes? Now we need, first of all, we first find how many are we having, the number of observations, the number of observations that they have given to us. Sometimes they may give you the observations when they are many. Maybe we call it n, letter n. Those are the number of observations. The next thing that we need to get is that we want to find the number of classes. So let our number of classes maybe be, you can call them letter k. So what we do from here, we can say, maybe we can also let our value k, the number of classes. You know these exponential values. You can let this k be an exponential, maybe the smallest exponential number. Let's say number 2. Maybe exponential k, then this is greater than n. So the implication here is that we need to find maybe the exponential, if this k to be the smallest exponential of this number 2, and the value that we get here should be higher than our number of observations. For example, if our n was 50 in terms of the number of observations they have given to you in the question, and then you want to determine how many can I have as the classes. Remember, we say that classes should be at least, the classes should be at least 5 to 20 classes within this range. So what am I going to do? The assumption is that at least I should have 5 classes, and that's our k, because those are the classes that we are trying to look out for. Now, this is what you are going to do. You are going to be doing some computation, just getting this, solving this small equation. You say it is 2, but at least I should have 5 classes. 2 power 5. The question is this greater than 50? Because our number of observation was 50. And we have found that this side is actually 32, which is less than 50. So it means if we are given 50 observations, we are not going to take 5 classes. They will exceed 5 classes. Then you add another number. You say, maybe instead of me taking 5, let me now take a 6. I see what is there. You go and put in 2 to power 6. The question I'm asking myself, is this greater than 50, which is our n? And you find the solution. 2 to power 6 is actually 64. So 64 is greater than the 50. So I can actually take a 6. I can assume that my classes are going to be 6. So you can choose k equal to 6, number of classes. I can take the 6 to be my classes because I've satisfied this condition that this is actually greater than this. The reason as why we use a greater sign here is because we want to accommodate all the observations that we have. Remember, we said you can't skip some observation. That's why we are taking 64 to be higher. Because if 6 classes gives you 64, it means that 64 observations can go in a 6 class. But if we are to use 5, we would only have 2 to the power of 5 is giving us 32. It means we will not accommodate all these values, this number of observations. So that's the small logic that you can use to be able to do the computation. But most of the times in the question, especially for CPA papers, you'll find that they may give you a starting class. But I'm giving you this just in case, because if I go by what happens, then we may not understand how some of the things are done. So that's why we are saying most of the CPA classes, they may tell you that we are starting with a class of 30 to 39. So if they give you this, then it's like they have provided for you the starting point. The reason as why they give you these classes is because they know that maybe within the question there are so many things to compute, depending on the marks that they have allocated. Because the moment you let this person to cut out everything, depending on the marks that you have allocated, most of the times they give less marks to the table, and then the marks goes to these other computation of mode, standard deviation, coefficients, and other stuff. Maybe we can have a simple illustration. Let's have a simple illustration. So example, this data represent the record high temperatures in degrees Fahrenheit for each of the 50 states. Full stop. The question: construct a grouped frequency distribution. Construct a grouped frequency distribution for the data using 7 classes. Construct a grouped frequency distribution for the data using 7 classes. Here they have given us the classes they want us to do these computations for. So let's have now the data set. This is 112. This is 110. 107. This is 106. 116. This is 120. This is 100. This is 108. This is 112. This is 108. 113. This is 127. This is 117. 114. 110. 120. This is 120. 110. 115. 121. 117. 134. 118. 118. 113. 105. This is 118. 122. 117. 120. 110. This is 105. 114. This is 118. This is 119. This is 118. There's supposed to be 50 observations. So this is 1110, 114, 122, 111, 112. This is 109. This is 105, 106, 104, then 114. Finally, we have 112, 109, 1110. This is 111, 114. So the data seems to be a little bit huge, but that's it. So we get our solution. Remember, we said the first step is to determine the classes, but they already determined for us the classes. They want us to do that work in what we call 7 classes. So if they want 7 classes, that's the step 1 will be done for us. Step 1 is 7 classes. Then our step 2 they want us to, we say we find the highest and the lowest value. Highest value was 134. Then the lowest value is 100. That is step 2. Step 3, we compute the range. We get the range, and we say the range is the highest minus lowest values. Highest minus the lowest values. So we get 134 minus 100. It's 134 minus 100. And this gives you 34. What is the fourth step? The fourth step is for us to find what we call the class width. And we said the class width is gotten by dividing the range over the number of classes. So we get the width. Step 4, we get the width. We get the range over the number of classes. And the range, we got it as 34 divided by 7. And the answer we are getting, it is 4.9. We said we round upwards. So this one will be equivalent to 5. So we are taking our class width to be 5. Don't take 6, it is 5. What will be the implication if I take 6? The classes will be more. Actually, if you take 6, the classes will be lower. They will not be 7. They will be like 6 classes. But if you take a lesser value, maybe you take 4. Now their classes are going to be more. That is the implication. So be careful. You can try it and you see, if I take 4, how many classes will it be? Because it means within these values, there are some values which we may not get. So when we are done with that, we go to step number 5, of course, where we select the starting point. We said the starting point can be picked from the lowest value. And that starting point is always our lower class limit for that first class that we are selecting. So step 5 is for us to select the starting point. And the starting point will actually give us our lowest class limit. And we've said that you can start with the smallest data value, which is 100. Or you can pick any value that is convenient. But for now, I can't pick any value that is less than 100. Maybe I pick 99. This will not be convenient for me if I'm adding mathematically. So I'm going to take the 100 to be my lowest, my starting point as the lowest class limit. Now, what do I do for me to get the upper class limit? Now, it depends on which class you want to form. If I want to form inclusive classes, then I'm going to get 100. I add our class width. Our class width was 5. And this will give me 105. Now, the 105 is not the value that I'm going to put here. 105, no. Because I'm making inclusive classes, I have to remove 1. You remove a 1 from here, you get 104. So the value I'm taking as my upper class limit will be 104. So this one will be 104. When I'm counting, because we say that when you are dealing with inclusive classes, we always use what we call the discrete data. We count. For discrete data, we don't measure, we count. So what we are going to do, count from 100 to 104, even 100 inclusive. 100, it is inclusive. 101, 102, 103, then 104. If I had included 105 here, those would be excess. So the reason why we take off a 1 here is because we always want to make a gap between my first class and then the second class, also the consecutive class, to have that gap. So what am I going to do to the next one? For me to get my lower class limit of the next class, which is the second class, I'll just get 100 plus 5. Or it will actually be, you'll get 105. Or you can use the upper class limit, you get 104 plus a 1. The other one that we removed because we want to create that gap, you put it here, 105. Then 105 plus 5, it will give you 110. We take off 1, it gives you 109. Because this value is inclusive and even this one is inclusive. Then on this one, you add a 1 to get 110. Of course, this will be 114. And you do like that until you complete. Because if I'm to get the class boundaries as my step 6, I'm just going to get this 100 minus 0.5. Why am I deducting the 0.5? Because of this one that I was creating as a gap. Because 0.5 plus 0.5 becomes a 1. That's why we took this one, we divided it by 2. It's like we are picking the extreme values. Then on this one, it will be 104 plus 0.5. So that if I'm to look for step 6 for the class width, I'll have this one as 99.5 to 104.5. When you less off these two, you will still get your class width. You will still get your class width of 5. But if you take this and this, remember, if you are to use these classes, if you are using class limits to find the class, if you are looking for the class width, we always use the class boundary. If you are to use the classes, you take this, the upper minus the lower. But if you want to use these classes, the class limit, you always take either the lower of the lower of the class and then the lower of the preceding class. You get 105 minus 100, that will give you 5. Even when you get the upper, you take now the uppers. You take the upper class of the second class minus the one for this minus this. You will also get a 5 as your class interval. So the class length or the class width. So don't take the other theoretical aspects that we gave slightly. Understand what they mean. So understand what those theoretical aspects mean. And that's the only way you are going to get the rightful application of those different terms. Especially for data set where they have not given you these values, and it's you to get these values and you do the computations. So the next thing is for us to tally. Of course, step 7 is for us to tally. We tally the data. Then step 8, we just count. We just we find the frequencies by counting the tallies. So let's now go to the table itself. We draw the table, then we summarize the information that we have. I hope we can be able to get this information right from the very basic. So we have the classes. Let me call them their names. Class limits. So that you get to an understanding. Then maybe let me put the class boundaries. Then I put the tallies, tally, and finally the frequency. This one I'm just going to use free like that. So we said we are starting with a class of 100 to 104. This is 105 to 109. From here, even if you just add, I add a 5 here, I add a 5 this side. This is 110 to 114, 115 to 119, then 120 to 124. One thing that we need to make sure is that we have 7 classes, because that's what the question told us to do. You see you have more, just know you have done some errors somewhere. That's the way you verify whether what you went through is right. This is 125 to 129. This is 130 to 134. I stop there because that's where the data ends as well. So now we count. Are we having 7 classes? So this is 1, 2, 3, 4, 5, 6, 7. That's it. Now we can compute the class boundaries. Of course, we said for the class boundaries, we just take this one. All of what is here, we get minus all of this. We take off minus 0.5, then this side we add plus 0.5. So we can have the values that we can have. Here we can have 99.5 to 104.5. Or there are options. You first get this plus 0.5. You first fill this side, the upper class limits. This is 109 plus 0.5, it will be 109.5. This is 114.5. This is 119.5. This is 124.5. This is 129.5. Then this one is 134.5. Now what are you going to do? Let me first remove this. Let me use a different color. We said for this one, we are just going to take 100 minus 0.5. This will be 99.5. Now, what we do, we just push this. You bring this side, this side, this side, this side, this side, and this one this side. You just take this 104, you take it here, 104.5. Then you take this one, 104, 109.5. Then you take this one, it will be 114.5. Or you can less, you can go and less 0.5 from this. But this will be easy. 119.5. Then this one will be 124.5. Then this one will be 129.5. And you are done. You just put in these dashes. Just put in those dashes and you are done. That's all that we wanted for that. What we are going to do for this is we are going to get the tallies. I want you to be very careful for this. So maybe we can go back to the other information we use. This is our information, so we are going to cancel. Let me use black. So 100 to 105, you moving downwards. 100 to 105. In this one, in this first column, we don't have. To 104, this is 100. Remember, we are stopping at 104. In this one we don't have. This one 104. This is 105. This is 105. This is 105. This is 105. We have 104 here. So there are only two numbers. From 100 to 104, we have only two tallies. So 104 to 109, can use a different color. 105 to 109. This is 107 is inclusive. This 108, because we are stopping at 109. Even this one is inclusive. This one is inclusive. This one is inclusive because we are stopping at 109. Even this one is inclusive. This one is inclusive. Even this one is inclusive. So how many are they? 1, 2, 3, 4, 5, 6, 7, 8. There are 8. We have not skipped any. Then you go to 110 to 114. 110, you can use maybe a different color. Let me take green. So 110, we are stopping at 1. It is 110 to 114. So this is 112. This is 113. This is 114. This is 110. This is 110. That is 15. We don't take it. 13 we take. 110. 111, 112, 114, 110. This. So how many are they? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Have we skipped any? Because this one seems to be very many numbers. We are stopping at 1, even this one, we had not seen it. So these are 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Those are 18. So we pick another color. Pick another color, maybe this. Now we are going to 115 to 119. This is 116, 18. This is 117. This is 115. This is 117, 18, 18, 18, 17, 18. It's up to 19. So these are how many? 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Even this one was 19. This one was 19. We skipped it. Those are 13. Then 120 to 124. Can choose another color. Maybe pick yellow. It is 120 to 124. 1, 2, 3, 4, 5, 6, 7. There are 7. Then of course these other ones that we have not yet cancelled it, they are belonging to the other last two groups. So those were 7. Now 125 to 129. You can also pick another color. We take this green. Now 125 to 129. 125 to 129, this one. Of course it's only one. We have not seen any other. Then the last one is 130 to 134. 134 is here. It's only one value because the rest are crossed. All of them are crossed. So we take these values to the table. We take these values to the table. We take these values to the table. So these tellings, the first one they had only 2. We put also its frequencies 2. The second one they had 8. 1, 2, 3, 4, 5, 6, 7, 8. Those are 8. The third one had 18. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10, 11, 12, 15, 12, 13, 14. That is 15. Then 16, 17, 18. Then the next one I had 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. But it's always better to cross those figures as you write. But you couldn't move back and forth. So this other one had 7. 1, 2, 3, 4, 5, 6, 7. then this other one had 1, then this one 1, 1, 1. So we add the frequency to make sure that we have the same 50. The summation f has to be 50 because they gave us 50 observations. So you'll find that this is a 10, 2 plus 8, that's a 10, plus 18, that is 28. 28 plus this, that is 29, 30. Of course, also this one is a 20. 13 plus 7, that's a 20. So 20 plus the other 30 becomes a 50. And that gives us what we wanted to look at as far as the table is concerned. So that's what they wanted us to do for that, and that's how we do all those other items. So it's all about us doing very many numbers, but I want to conclude this chapter and we look at chapter 5. Of course, chapter 5 is all about presentation of data, but this time around we are using charts, we are using graphs, and we are using pictograms or pictures. We are going to look at very many graphs that we can do to make sure that we can be able to present data. So these are the things that we are going to look at as far as chapter 5 is concerned. So we are going to look at chapter 5, where our emphasis is about the graphs, where we shall do the histogram, the bar charts, the frequency polygons, the ogives, the stem and leaf, the box and Wixar plots, the Lorenzo curves, the Pareto curves or graphs. So those are the things that we are going to look at. So this is all about data presented in pictograph, pictograms, charts, and then graphs.